fine.
Okay, yeah. So good morning, good afternoon, good evening from my side as well to everyone, since I know we have people joining from all parts of the world. And before we jump into the session, I just wanted to tell that this is my fifth consecutive appearance at Data Weekender as a speaker. So I just wanted to thank you guys for accepting my bribes over time, and hope that will continue also for the next year.
Thank
Just
you so
kidding,
much,
but
Nicola.
always
Keep
happy, always
yeah,
happy
keep
to be
send
part.
keep sending those sweets and treats from there, okay?
Sure,
We'll
sure.
get you again next
I will.
time.
I will. Okay, so before we jump into those five things that people forgot to tell you about Power BI, a few sentences about me. I'm Nikola. I'm born in and raised in Belgrade in Serbia, but for the last almost 8 years, I live in wonderful city of Salzburg in Austria, where I work as an independent data platform consultant and trainer, focusing mostly on Microsoft Data Platform products and specifically Power BI and recently Microsoft Fabric, of course. Living in Salzburg was the reason why I've chosen my nickname Data Mozart, because probably you all know that Salzburg is worldly famous as a birthplace of Mozart. So I was brave enough to use his last name as part of my nickname, and that's why I'm trying to make music from the data. You can find me on web. I'm regularly blogging at data-mozart.com. I'm also active on social media like LinkedIn, Twitter, Blue Sky, so feel free to connect if you like. Privately, I'm huge football or soccer if you're coming from US fan, and specifically I'm supporting Barca since 90s, so I'm pretty old, as you may assume. Uh, okay, so what's in for you in today's session? I call these 5 things you won't find in docs, in documents, and 5 things you won't find in courses. Now, I was a little bit dishonest here because maybe 1 or 2 things you will find in documents, but I wanted to stress them here additionally because I think that people are sometimes not aware of their importance and the impact of some of these things that we are going to discuss today. But for at least 3 or 4 of them, yeah, I can bet that it's really, really hard to find them anywhere. So that's why this session is not a beginner friendly. And I feel obliged to warn you in advance that first of all, this is not a beginner friendly session. So I will assume that you already had some exposure to Power BI and that you know some of the concepts because we don't have time to cover everything. And also another disclaimer, this is not a session for data visualization wizards. There were many amazing sessions today on data visualization topic. So I will show you some of the charts in my Power BI report just to demonstrate performance things, but it's not a session that will teach you how to build visually appealing reports. Of course, that doesn't mean that you should now leave the session. Please don't do it, but you have been warned, and I expect from people who are present at this session to have at least intermediate knowledge about Power BI and tabular modeling in general. So this is our agenda for today. We will kick it off by explaining DAX Fusion. Then the next topic is, I called it Cache Me If You Can. We will talk about different cache types in Power BI. Then dark art of table processing. You will see why it's called dark art, because there are many potential caveats on this road. Fall on tide, this is related to query folding, one of my favorite topics in Power BI. And finally, we will wrap it up. I will share with you one of the secret sauces of professionals, and you will see why I call it this way. So stay tuned. These are 5 things that you will hardly find anywhere except in this session. So let's start with DAX Fusion. And so what is DAX Fusion? Sounds like some term from physics or something like that. It somehow it's related to this. And in terms of DAX, in terms of Power BI, we are talking about DAX Fusion as an optimization technique that reduces the number of storage engine queries when the engine detects that multiple calculations can be merged together in a single query. There are 2 types of fusions to be aware of in DAX: vertical and horizontal fusion. Vertical fusion occurs when multiple measures or calculations in general need to be computed in the same filter context. You can imagine something like you have a table and you need to display the data within the filter context of November 2023 for different products. You need to display sales amount, total order quantity, and so on. So you have multiple different measures within the same filter context. That's vertical fusion. Now we are talking about horizontal fusion because it's more interesting, and there were some recent enhancements in these areas that it's good to be aware of. So in September 2022 version of Power BI, so yeah, slightly more than a year ago, Microsoft introduced a different type of fusion optimization, which is called horizontal fusion. Horizontal fusion aims to reduce the number of storage engine queries when there are similar calculations that differ only by the filters applied to a column in the filter context. Opposite to vertical fusion that we mentioned, we have same filter context, different calculations. This one, we have the same calculation, but different filters. I will explain you in a demo. It's easy to understand. Horizontal fusion will work if those different scans can be grouped, can be fused within one same query. And the main idea behind horizontal fusion is, of course, in most cases, it provides much better performance for your Power BI report. As I said, it's available out of the box since September last year. Before that, we had to write some DAX to force this horizontal fusion. Thanks to Microsoft, it's available out of the box since September. I will show you how it works, and I will also show you one edge case where you can additionally optimize this out of the box solution that comes for you within the Power BI. So before September 2022, this is how horizontal fusion worked. So let's say that you have a query that needs to calculate sales amount for different product categories like computers, cell phones, and audio. So before September 22, you would get three different queries, three separate queries, each one calculating value for the specific product category. After September 22, it all goes into one query. So one query will scan the table and return the data. That's the benefit of horizontal fusion. Also, one thing to keep in mind before we jump into the demo, horizontal fusion, even if it comes out of the box for you, will not work in each and every scenario. So if you're using visual types that by their nature produce just one single value, like card visual, old card visual, not the new one. So card visual produces always one single value. Then there is no benefit of horizontal fusion. So you will again have three separate queries. But if you, for example, use table visual or matrix visual, then horizontal fusion kicks in and it will improve the performance of your calculation. So let's jump into Power BI Desktop, and let me show you. As I said, in this demo, we will cover one edge case, but in certain circumstances, for this edge case, you can additionally improve the performance by basically extending the logic of DAX Fusion. So what we have here is, simple table visual, and I'm using Contoso sample database. As usual, you see we have a total sales amount, and then I've created three separate measures. Let me show you. So this one calculates total sales amount for all the products with black color. Same logic is for blue and same is for brown. And here in this final measure, sales BBB, black, blue, brown, I'm just basically adding up those values to get the final result as sales BBB. Okay, so whenever we want to troubleshoot performance and see what's happening, of course, our best friend is DAX Studio, and I think I already have it here. So essentially, this is the measure I've written in Power BI, and I turned on server timings and query plan because we want to analyze what's happening with different approaches for writing this text measure. So if I execute this measure and go to server timings, of course, this is super simple. So, and we don't have really huge amounts of data, but still this should produce a difference in performance. Maybe I can reconnect because it looks like DAX Studio didn't really want to cooperate. So let's start from the scratch. Server timings, query plan, and execute our query now. As you see, here is my query, and it returned results in 37 milliseconds. Don't pay too much attention at this moment at this timing, but I just want to show you the difference in the query itself. So what I wanted to show you now is if I open this sales BBB measure, right click on it and define dependent measures. Basically, I will get all the measures that are that are part of this final sales BBB measure. So this is the measure definition, and all dependent measures are here. You see blue, black, and brown. If I now execute this query, again, we will have the same query plan. And what's interesting here is, let me zoom it a little bit. So even though we are displaying data in the Power BI report in the context of the brand, so we are not displaying colors, the engine will also include in the scan color name, value of the color name column. And you see that it will scan the fact table 3 times. So for each of our colors, for black, for blue, and brown, it will perform a separate scan. In this case, as I said, this is a small, relatively small table, but in real life, what I did with this approach for 700 million rows table, it was a huge time saving, and you will see why. So if we go to query plan, and let me expand the physical query plan, the interesting thing to point out here is basically there are 5 times here that data is materialized. And the time spent in Formula Engine in this case is not so big, as I said, because the estimated number of rows is 10, 11, and 6, so it's not so huge. But still, this is not the most performant, the most optimal query, because it basically performs 3 scans of the fact table. So what we can do in this case, let me just change this measure. So I will first comment this, and I will change the measure definition to include blue, black, and brown. Close the curly bracket, and I don't need this one. So let's comment them. And if I now execute this query, okay, something. Let's see what happened with our syntax. Probably miss another bracket or something. No. Sales BBB, okay, equals, okay. Let me try now. No. Let me check what's broken here. I need this one for sure. So I will uncomment, and it equals. So this one I don't need. Sales. Aha, I don't need this. No.
I think, Nicola, on line 22, you have an open close bracket. Maybe that needs to be
You are
called
right.
out.
Good catch. Good catch. Thank you. Thank you. And then let's see if it works now. It's always interesting with live demos. This one is closed. That's fine. Summarize columns, sales VV. Let me see what it complains about. This one should be commented. No. Let me check if I have this in another one. Okay, so I have this. That's fine. Uncomment. Comment. Okay, now it worked. Let me turn on and execute again. So in this case, when we rewrote our DAX measure, I don't need those three anymore. So when we rewrote, remember in the previous case, the query was scanning also color name column. In this case, it doesn't happen anymore. And unlike in the previous case where we had 3 times scanning of the fact table and calculating, basically performing the same calculation 3 times, this time it performs just once. So it goes once through our fact table and retrieves all the results. In this case, it's faster, not significantly, because as I said, it's super simple calculation. It's not so big model. On 700 million row table, it was in order of magnitude of like 5 times faster. Now, one important remark here, and I want you to remember this, this is definitely not a best practice to do it each and every time. So from maintenance perspective, for complexity of your DAX code and maintaining this solution in the future, this one is definitely not the best solution. But I wanted to show you how you can stretch what is provided to you out of the box with horizontal fusion. And in certain cases, if you have a super huge data model and you have a calculation that blocks basically that is super slow, you can introduce, for those edge cases, you can introduce this approach and push this DAX fusion basically to perform even better than it performs out of the box. Okay, so that was about DAX fusion. The next topic is another interesting one about different types of caches in Power BI. And I think we all been in this situation that when we open the report for the first time, our page takes a while to render. But once we go back and forth through the other report pages and we go back, the same page renders significantly faster. That's happening because Power BI caches the data and it can respond much faster after that first initial data load. Even though it sounds easy, it's not just simple as that. And this part of the session will try to demystify different cache types in Power BI. So let's kick it off by explaining on the demo different or let's say two main cache types from a high level perspective, and then we will go deeper to explain some of the nuances for each of these cache types. So I'll go back to my Power BI desktop, and as you see, I have a super simple report page with one bar chart visual and one slicer on this report page. So I will turn on first performance analyzer and I start recording. And let's say that I want to see only numbers for Contoso. So once I click on Contoso, within performance analyzer, I will expand my bar chart information. And here is the option to copy this query. So I can take this query and move to DAX Studio, for example, and then go and troubleshoot this query. Now, if I click on Litware, again, copy query option is here. Let's say that I want to go back now to Contoso. So if I click on Contoso, this option is now grayed out. This means that there was no query generated by the formula engine this time, and the data for this visual was served from the cache. In this case, we are talking about the visual cache. The same will happen let me show you. If I go back again to Litver, again, copy query option is grayed out. Now if I click on refresh visuals, so with Litver selected, copy query option is again here, because once we click on refresh visuals, visual cache is cleared by Power BI and Formula Engine generated DAX query once more. Obviously, this is a super basic example, and it's not easy to spot a significant difference in performance between those two scenarios. But in reality, we usually apply more complex logic, and retrieving query results from the cache is usually dramatically faster than running the same query over and over again. Okay, so if I take this query and move to DAX Studio, let's open a new instance. So I will turn on server timings and I will turn off clear on run, because I want to show you what happens when we don't clear the cache here. Okay, and here is our query. I will execute it and go to server timings. You see we have one storage engine query. Here it is. And this query was served from the cache. As you can see, storage engine cache, one query was served from the cache. If you don't trust me, I will turn this option cache here, and here is my query that was served from the cache in this example. Okay, so in this example, we explain how Power BI will cache query results when we are working with Power BI desktop in this local instance of analysis services. Now, the fair question would be, what happens once we move to Power BI service? Does this cache trick will still work? The answer is yes. Yes, it will. But in this case, it's done using your web browser. However, keep in mind that this type of cache, visual cache, has a scope of the specific individual Power BI session. We will come later to explain in more detail how this works. Then there is another type of cache in Power BI, which is called data cache. Unlike in the previous scenario with visual cache, where caching occurs on the level of the individual report user, data cache operates on a higher level, the level of the analysis services tabular model. So as I said, I assume that you are aware of internal architecture of Power BI and tabular model in general. And then I assume you also are probably aware that Vertipack database behind Power BI stores our Contoso data in memory in a compressed way. So what exactly happens when we ask Power BI to calculate the total sales amount for Litver brand, like here? Formula Engine generates and executes a DAX query, but then storage engine translates DAX to this special dialect of SQL, which is called XM SQL, this one here. And it helps with this XM SQL, it helps storage engine to physically pull the data from the tabular model. Okay, so for every of these XM SQL queries, there is a special data structure which is called data cache. And this structure is stored in memory, in RAM memory. So server timings are turned on. And as I show you, in this case, this query was retrieved by using storage engine, by using cache. If I clear the cache and execute this query again, you'll see now that the whole process starts from scratch. We don't have anything in the cache, so this query couldn't be executed from the cache. Now, there are some things to keep in mind regarding this data cache. And I would say there are at least two important considerations to keep in mind related to data cache. First, it may trick you to think that your query is running fast, although it might not be true. So let's say that you're troubleshooting a poorly performing query, and you take the query into DAX Studio, like I did here, to get more insight about what is happening in the background. And you execute this query for the first time, and let's say it required 2000 milliseconds to return results. You go then and apply some minor changes to this query, and you execute query again. And now it renders in 100 milliseconds. Yeah, you start thinking, okay, why everyone is saying that DAX is hard when it's not? So I just reorder lines in my code and it works 20 times faster. Yeah, right. The next morning you get another call from the report user. They're again complaining that the visual renders slow. So you probably forgot to clear the cache before running this so-called improved version of the DEX calculation. As I showed you, if you clear the cache and run the query again, then you will get realistic results. So you should, whenever you're troubleshooting your DEX queries, don't forget to clear the cache before you try and test your improved solution. Now, again, what I wanted to show you is that not all queries can be cached within the analysis services. This one was super simple and it doesn't return a lot of data, so it could be cached. But depending on the amount of data that you are retrieving by the query, it may happen that only some small portion of storage engine queries can be served from the cache. So let me show you again example of how this affects caching of the queries. So in this case, I have just a short introduction to this report page. I have a year, I have a brand, and the number of distinct orders for every year and every brand for the current year and for the previous year. So nothing special, but we have data from 2007 to 2010. Okay. And let's grab this query. So I will refresh my visuals, copy this, and move to DEX Studio. Let's execute this query without clearing the cache. So I just want to capture server timings. We got in 13 milliseconds, we got our results. There are, let me zoom it a little bit. There are 13 storage engine queries and all 13 storage engine queries were served from the cache. That's ideal example. So we got results super fast because everything could be served from the cache. As I said, the amount of data retrieved here is very small. Now what happens if I want to, for example, include dates instead of years? Let's see now. So you see it's spinning, it's spinning, it's spinning, meaning that takes some time. Yeah, it was 19 seconds. I go back to DEX Studio and let's execute this one. So now we again need to wait 19 seconds. But the thing we want to focus on is how many of these storage engine queries were served from the cache. It's here, so 18, almost 18 seconds. So to explain what is happening here, when the query executes, storage engine retrieves the data and materializes those intermediate query results in a special structure which is called data cache. And this data cache is finally consumed by Formula Engine before the final results set goes back to the report. Now, depending on many different things, obviously, sometimes all the necessary data can be materialized within one data cache. That's ideal scenario. But sometimes it may happen that there is simply too much data to be scanned and materialized. So storage engine creates multiple data caches. In this example, I hope that we will soon be able to see results. Yeah. In this example, scroll it here, we have 2,000, more than 2,000 storage engine queries. They're super fast. You see that it's less than 10 milliseconds per one query, but there are many of them. And in the end, this produces almost 18 seconds. Now what happened, for example, if I change this to, let's go back to our report, it's easier. And I change this to, for example, let's go to 2009, 2010. Let's do 1st of February 2010. Let's see if that helps for the engine to take data from the cache. Again, I will copy this query, open in DEX Studio, run all the same things, all the same steps like in the previous case. Now it's faster because we don't scan 3 years of data, we just scan like maybe 1 month or so. So let's see if this one goes from cache or not. Whenever I'm doing this session in person, I like to ask people while we are waiting what they think. Will this be served from cache? Unfortunately not. Oops, I pressed the wrong one. So unfortunately not. We have a lower number of queries. Instead of 2000, we have 700, but just 2 of them were served from the cache. Now, if I go back and let's say I use 10th of December 2010, and let's grab this one, move to DAX Studio, and execute this one. So this one is super fast. Let's hope that now everything is served from cache. Yes, as you can see, 394 storage engine queries, 394 served from cache. Instead of 4, 5, 18 seconds, it's just a fraction of a second, 118 milliseconds. So what's the moral of this story? It's important how much data you retrieve. That doesn't necessarily mean that data cache will kick in each and every time. Depending on how much data your query retrieves, it may happen that data cache is not able to serve each and every time. Caching query results, one of the key performance optimization concepts to keep in mind, and this is a visual representation of what's happening within and what is the difference between the visual cache and data cache from the user perspective and from the perspective of analysis services instance that stores the data for your Power BI report. Important things to keep in mind: visual cache or report cache, data is cached in the scope of the specific Power BI session. Nevertheless, if we are talking about the session in the Power BI desktop on the local machine or session in Power BI service, and data is cached in the scope of the analysis services instance, nevertheless of the number of opened Power BI sessions. Okay, so we are moving to X file number 3, dark art of table processing. And first of all, I would say processing tables assumes loading the data into our data model. Depending on how much data we load, it may happen that the processing takes a while. The goal of this section of the session is to introduce various processing options in tabular and give some hints about optimizing data processing. Don't be afraid, processing data in tabular is fairly simple. The trickier part is to understand what is going on under the hood. But I would say that's usually the biggest problem for the other things as well. So let's start with a short introduction of Vertipack. We already mentioned Vertipack in the previous demo. That is a database engine behind the tabular model. First of all, let's draw the line between the row store and columnar databases. In traditional relational row store databases, data is stored as a sequence of rows, whereas in column store databases, data is stored in columns. And in this system, each column represents a single unit and is physically separated from other columns. The other important distinction in Vertipack is 2 different engines, formula engine and storage engine. You can see the simplified architecture in this illustration taken from the book Definitive Guide to DAX from Marco Russo and Alberto Ferrari. And we want to focus in this specific scenario, we want to focus on explaining this portion here. So at this moment, we are not interested in direct query. We are interested in this part here in Vertipack and DAX calculation engine, which is basically formula engine. So these 2 parts we will cover in this session. So let's briefly introduce the flow of what is happening when you choose to use import mode in Power BI. As a first step, Vertipack will read the data source. Think of SQL database, Excel file, and so on. Then it will encode and compress the data. Discussing encoding algorithms is out of the scope of this session, but just briefly keep in mind that there are 2 main encoding types. Value encoding type, which works exclusively with integers, and hash encoding type, which works with any data type. This latter hash encoding is the most common, and when applying a hash encoding, VertiPack establishes a dictionary of distinct values, and that is the third step in the import mode workflow. After that, VertiPack creates relationships and takes care of all DAX calculated columns and DAX calculated tables. Now, when you process your data model, two things happen in the background. We first load the data into tables, and then recalc process kicks in, which is applied to handle additional data structures such as relationships, hierarchies, calculated columns, and so on. And if we go back to our previous illustration, the first three steps belong to this data part of the process, whereas the last two go under recalc. Now, there are three different levels, or maybe it's better to say scopes for processing options. Database represents the highest level, which consists of one or more tables. So one database can have one or more tables. Each table contains one single partition by default, but you can also split tables into multiple partitions, which is, I would say, a quite common scenario when you're dealing with huge tables with tens or hundreds of millions of rows of data. When you refresh your Power BI data model, by default, the engine will run the process default option, which checks the current state of all the objects, and if it's necessary, process these objects in order to bring them into a fully processed state. However, the choice here is more nuanced, as you may want to apply different types of processing. Without going deeper into explaining each of these types, because you can download this presentation and read at your own pace, let's talk a little bit about choosing the right processing strategy. Table partitioning. So if you're thinking about table partitioning, this is out of the scope here. We want to focus on the data processing part itself. And one of the most common strategies is to apply process data on each table and partition to get the updated dictionaries for each column. And then once you are done with all the tables, you just perform process recalc on a database level to get relationships, hierarchies, and calculated columns in the latest state. Please keep in mind, if you decide to go with this strategy, be aware that structures which are handled by step 2, we are talking about relationships, calculated columns, hierarchies, they will not be available to end users in the window from the start of process number 1 and the end of process number 2. If this process takes 1 minute, then you are good to go. But if it takes a few hours, maybe you need to reconsider your data processing strategy. Talking about choosing the right strategy, how do you know if you have a bottleneck in the data refreshing process? Or even more important, if you have a bottleneck, how do you know how to identify it? I have good news for you. A guy called Phil Simark, who works at Microsoft, he has a fantastic blog at dex.tips. It's full of great tips and tricks and some creative ideas. And one of his blog posts explains how to visualize the data refresh process, and not just how to visualize it, but you can also grab a free PBIX file, adjust some parameters, and analyze the data refresh process for your own models. It's the quickest and easiest way to identify potential bottlenecks in the data refresh process. Okay, so I wanted also to show you a short demo how you can leverage SQL Server Management Studio to identify unprocessed objects and how you can quickly process them. So I will right click on my database and execute new MDX query. Let me see if I have my statement here, so I don't need to write it from the scratch. I'll execute this one. So essentially this query will return, let me zoom it a little bit, all the tables and all partitions from my data model. In this case, whenever you see that state equals 1, that means that all your objects are processed. Whenever you have different number than 1, then that means that the specific object is not in the latest process state. So let me show you how you can identify this. If I open tables, okay, maybe needs to refresh this because token expired. And I'll open this script table, create or replace to. Let's make some dummy change just to show you how to capture this. So for example, I'll go and change this size unit measure code. I will just add test in the end of the name of this column. So size unit measure code test, and I'll execute this query. Okay, and now if I run this one again, you see that now for dim product, it says that state is 8. So now I immediately know that dim product is not in the latest state. So what I can do, right click on it, process table, and then you can choose between those options that are mentioned in the table that you saw in one of the previous slides. In this case, let's run process default, and it will take maybe a minute or two to process it. Ideal moment for me to grab some water. Let's wait, and then we will execute this command again just to check that now all of our objects are in the processed state. Okay, it was successful, and now let's execute again this one. Now we have all ones here, that's good. And what I wanted to wrap up with this portion here, taking it a step further. So there is a solution to automate the entire process I've just shown you in SQL Server Management Studio. Michael Kowalski, another guy from Microsoft, created a script that checks for you all unprocessed objects, and once identified, they will be automatically processed. Check this link that is included in the presentation. It's a very handy solution. Number 4, query folding. Let's first explain what is a query folding. For some data sources, such as relational databases, but also for some non-relational data sources, for example, all data, Active Directory, or maybe Exchange, Mashup engine, the engine behind Power Query in Power BI, is able to translate M language to a querying language that this underlying data source will understand. In most cases, we are talking about the SQL language, of course. What's the idea? Why is this important, and why you should always strive to keep query folding in place? Essentially, the idea is to push all the complex transformations, filtering, aggregations, and so on to a data source side, because those relational database engines are created with that idea in mind to deal with huge amounts of data in the most optimal way. And this ability of Power Queries engine to create a single SQL statement that combines all your M transformations, all your M code behind your transformations, is what we call a query folding. As I already mentioned, the most obvious beneficiary of query folding concept are relational database engines. You can think of SQL Server, Oracle, MySQL, and so on, but also some non-relational sources like SQL Server Analysis Services, OData, Exchange, and so on. For some data sources, it's not possible at all to achieve the query folding. For example, Excel, there is no, unfortunately, at this moment, there is no querying language for Excel, so we cannot expect a query to be pushed and executed by Excel. Also, blob storage and similar data sources also don't support query folding. However, when it comes to data sources that support query folding in general, that doesn't necessarily mean that all your transformations will fold. So there are sometimes some subtle differences in things that you perform, in transformations that you perform within Power Query, that can either cause query to fold or not to fold. I listed here some of the most common transformations Those on the left-hand side will, in 99.9% of cases, fold. Those on the right-hand side will break the query folding, except this one, changing column data type. Depending which transformation type you apply in Power Query, it may happen, so it can go either way, either with folding or without folding. Why should you care about query folding? Data refresh process, first, that's the first and most important thing. Data refresh process will be way more efficient. If your reports are using direct query or dual storage mode, the query must fold or your report will not work, simply said. And with the incremental refresh, it will not break the incremental refresh per se, but without query folding in place, you will load the whole data basically, and you are losing the benefit of incremental refresh concept. One more important to keep in mind: if your report is slow, if your visuals are rendering slow, if you have a large data model, there is nothing to do with query folding. So query folding is just relevant for data refresh process and incremental refresh. One more important thing: it's not all or nothing process. So if you have a Power Query transformation pipeline that folds up until 5th step, you will still get some benefit of partial query folding. However, once you break it, it can't be achieved anymore. So even though you have some transformations that are listed as foldable, once you break the folding process, the query folding cannot be achieved anymore. Therefore, whenever you identify the step that breaks the query folding, and you simply need to use it in your Power Query transformation pipeline, the idea is to do this. So in case that this merge columns step breaks the query folding, move it down below. Then you will increase this green rectangle to all the previous steps to that one that breaks the query folding. How do you know with the query faults? There are multiple different ways, but the most reliable one is to right-click on the transformation step and check View Native Query option. If it's disabled, like in this example you see on your screen, that means that your query probably doesn't fall. I said probably because for some data sources it will show you that it's grayed out even though there is a query folding. So don't trust it 100%. And if it's enabled, then that means that your query is folding. To be 100% sure, you can use either Query Diagnostics tool in Power Query Editor or good old SQL Server Profiler. Also, there is a feature in Power Query Online where we will see all these nice icons for each step, so you don't need to click on the individual step. You will see if the step is foldable, if it's not foldable, or if it's unknown. Hopefully, this feature also reach Power BI Desktop sooner rather than later. I'm afraid we don't have a time at this moment for query folding demo, so I will skip it because we need to cover 5th act file, and then in case we have enough time at the end of this session, I will go back and show you why should you care about query folding. So this one, I promised, this one is related to professionals, and you know why is this related to professionals? Because professionals using external tools to enhance their Power BI development, and this file number 5 cannot be learned and understood by using exclusively Power BI Desktop as a development tool. At least at this moment, we will see what happens in the future. So let me show you what I'm talking about. I would love to see all of you now, and I would ask you to raise your hands, everyone who recognized good old MDX. Maybe it's just old, not so good, but anyway. Okay, I see some hands in the chat. Thank you. For those of you who are not aware, MDX is the language for querying SQL Server Analysis Services multidimensional models. And SQL Server Analysis Services creates automatically for you a structure called attribute hierarchies. And that structure looks something like this. So you get this out of the box in SQL Server Analysis Services multidimensional. But what's the deal with attribute hierarchies? Deal is that you can use a column from the hierarchy both as a row and as a column in your MDX query. Okay, now that's also nice, but what's the deal with MDX at all? Why am I keep repeating MDX and MDX? And Now you're probably wondering if you're at the right session. I mean, you know that Power BI is all about tabular, all about DAX, not about multidimensional, not about MDX, right? So the fair question would be, what on earth does MDX have in common with Power BI? Instead of answering, I will ask you a question. Which language does Excel use when connecting to analysis services tabular model? And I will give you a hint, it's not DAX. So yes, Excel generates MDX queries when connecting to analysis services tabular model. And this brings us to a key takeaway here. As Excel relies on MDX, it also relies on the data structures that are present in the multidimensional model, including attribute hierarchies. Uh, Maybe you didn't know, but there is a property called is available in MDX within the tabular model. And by default, this one is set to true. This implies that unless you explicitly go and set this is available in MDX property to false, the attribute hierarchies will be part of your data model. Now the next question is, why this property is not by default set to false? Well, this is how your Excel users will look if this property would have been disabled by default. In many real life cases, let's be honest, Excel is the tool of choice for many data analysts. And they should be able to connect to analysis services tabular model and use their pivot tables to analyze the data from the Power BI dataset. So if you turn off this is available in MDX and you kill attribute hierarchies, they shouldn't be able to perform their analysis. What's even more interesting, most of the Power BI developers are not aware of this property at all. And why they should? I mean, I don't blame them. It's not accessible from the Power BI desktop, at least now. Attribute hierarchies are not visible in the Power BI desktop at all. While in the Power BI itself, you will not notice any difference in the figures displayed in the visuals. So why bother with it when everything works perfectly in Power BI, while your Excel analysts are happy with creating their pivot tables using the data from the Power BI dataset? It's okay when the dataset is small, but if you deal with large amounts of data, this is the point when this thing may be super important. So there is a great blog post written by Chris Webb, another Microsoft guy. Yeah, their Web is full of their resources and they're great. You can read this Chris blog and understand what is the difference between Excel and Power BI when displaying data stored in tabular model. In this case, I just want to show you a quick demo how you can save some space and some memory if you deal with this feature in your Power BI report. So let's go and open Tabular Editor. You can use both Tabular Editor 2 and 3. In this case, I'm using the free version, Tabular Editor 2. And let's go and open our fact chat table. But before that, I forgot to do a very important thing. Go to DAX Studio and see the total size of the tables that I have in my data model. So I will go to Advanced tab, View Metrics. And here you can see the total summary, total size of all the objects in your data model. Let's focus on this fact chat table because I will mess up with this one in the demo for is available in MDX. And I want you to focus on this information here. So hierarchy size. These numbers are in bytes. So hierarchy size for chat ID is 37 megabytes, for IP address is 8 megabytes, and so on and so on. So those three here occupies 50 megabytes of our data model. So let's go and see what happens if I go to Tabular Editor and chat ID. Here, available in MDX, here it is. By default is set to true. I will just switch this to false. And let's do that for also IP address ID. I will just do for those two. False, and I'll save back those changes to my report model. Let's refresh this one. and expand fact chat. So now you see that it's 0 and it's 0. So do you need to turn this off each and every time? Obviously, it depends. We will come up soon to explain on what does this depend. But if you disable this for all the columns in your data model, that means there is no Excel analysis at all. But still, what you can do for all the ID columns and for all numeric columns, there is a very, very small chance that someone will slice and dice data in Excel using ID columns or numeric columns. Doesn't make sense. So you can be sure that if you disable this property for those columns, you will 99% will not kill anyone's dream of using Excel for data analysis. And lesson learned from this is available in MDX thing is there are many hidden gems in tabular model. Some of them are really hard to find, but understanding their potential impact can really make you a true Power BI hero in certain scenarios. In this case, it increases efficiency and keep functionality of the report. So that's a win-win situation, both for you as a report developer and for your Excel users. However, I feel obliged here. As I said, there are some considerations to keep in mind. I want to warn you about the possible implications of decision to disable this property on certain columns. Attribute hierarchies store some important information. Of course, they are not here just for the sake of, nothing. For example, number of distinct values in the column also stored in alphabetical order, so kind of an index for this column. So consequentially, if you frequently use operations such as distinct count, min, max over one single column, so without including filtering results by another column, tabular model that has this is available in MDX property enabled, so without removing it, could perform better. So again, in the end, should you disable or enable this property? As usual, it depends, but keep it in mind. To summarize what we covered today, first we talked about DAX Fusion, very, very cool feature that Microsoft introduced out of the box last year, which can be additionally extended in certain edge cases where you face slow performing queries. You can, with some DAX rewriting, you can force it to work faster. Then two types of caches in Power BI, visual cache, which has a scope of the individual session, data cache that has a scope of analysis services instance. Then we were talking about some tips and tricks about table processing. Don't forget, the usual way is to process data in tables and partitions, and then use process recalc for the whole database to speed up the overall processing workflow. We talked about query folding. Unfortunately, we don't have time to do a demo to understand why is this important, but keep in mind, I need to quote Alex Powers, don't break the fold. Whenever you can force query folding, try to do it. And finally, this secret sauce of professionals, I show you hidden little gem within the tabular model that can make you a true Power BI hero when dealing with huge data models. That's it from my side. Thank you very much for listening me.